Good morning, guys. I'm sorry I wasn't able to make it to class today. Not feeling the best. I hope that you guys are doing a good day. I put in all of your test grades already, so if you haven't seen those, you can look at them in Skyward. For today, I'm going to ask that you have a piece of blank white paper. If you don't have white paper and you have like colored paper, that's fine. If you have just lined notebook paper, that's okay too. But if you do have just like a sheet of white printer paper, that's going to be the best thing for you to use because we want to be able to like see through it and we don't want it to be too busy. If you have a Sharpie, a dark colored Sharpie, that would be best. If you don't have a Sharpie, any kind of marker or pen will work, but preferably if you have a marker. So like if you have a regular, like just like Crayola marker versus a pen, the marker is going to be better. We want it to soak through the paper kind of. And then you either need a ruler or a straight edge. So like I don't have a ruler at home. I have this paper, I have a straight edge. So that's what I'm going to use. You can just use another piece of paper as straight edge, it doesn't matter. Okay, so we're starting unit 4, which is about parabolas. So what we're gonna do is we're gonna make our own parabola and we're gonna talk about some of the things that go into it. So I'm hoping this will, hold on just a second. Okay, so I hope that you can all see my paper. I'm gonna turn it long ways, sideways, so you can see it. Like all of it, I guess. Okay, so what we're gonna do is we're gonna take our straight edge and on the, this might not work, I can't really see. So like on the shorter here, I'm just gonna do it this way. This is just gonna work better, I think. Okay, so on this edge, at the bottom, the skinny, you're gonna take your straight edge and you're just gonna draw a line close, like from the middle down to the bottom. It doesn't matter where you put it, you can just kind of pick a place that you like. So I'm gonna do it right here. And just all the way across, draw a line. Like I said, the more saturated, the better, because then we're going to be able to see through the paper. We want this to bleed through. So if you're using a regular marker, I would suggest going over it like 2 or 3 times. Just to make it easier. All right. So there's my line. It just goes across. Now, we're going to put a dot above the line. So kind of try and center it this way, like from side to side, like in the middle. It doesn't matter how far up or down you go. I like to keep mine not that far from the line. So I'm just gonna put mine right there. You can put yours wherever. Okay. So if anyone's confused at the moment, this is what your paper should look like. Okay, you should have the line and the dot. Cool. Okay, hold on, now I have to fix my camera again. Maybe I shouldn't have moved it. Okay, so now what we're going to do is we are going to fold our paper so that our line goes over our dot. Okay, so like our first fold, I'm just gonna line it up. So see how our line touches our dot? And I'm gonna make a crease. You wanna make these creases. The creases are important. This is why we're doing it. Then I'm just gonna scoot it up some. So I guess it's kind of hard to tell on camera, but in person you can tell. So see how I can kind of see my dot underneath? I want my line to overlap my dot. Okay. And I know that's hard to see on video, but that's kind of why we use the Sharpie, because we want to be able to see both. So then I'm going to slide up my line some more to do another crease. Now this whole time, my line is crossing over my dot, and you guys can't really see it. My dot's right there. Okay. And again, I'm just going to keep doing it. I want a bunch and a bunch of creases. The more creases I have, the more accurate my drawing's going to be. Okay, so I'm still just rotating my paper so that my line overlaps my dot. See, my dot's right there still. And just keep doing it till you have a whole bunch of creases. The more the merrier. There will be one where you're basically just folding the paper in half like this, like where you're just folding the line over the dot. That's okay, we want that. That's good. That's an important one, actually. We really need that one. Okay. So on your left side or your right side, whatever side you started with, there should be a whole bunch of creases. That's good. Now we're gonna go the other way. Right? So put the other side against the dot and just slowly move it up so that your line is on top of your dot. We want a whole bunch of creases. Oops. Sometimes you'll get a little bit lost, and that's okay. And you just gotta look and see where they overlap. It doesn't have to be super perfect, just do your best. Yay! Cool. So now you should have all these little creases, right? I can't actually see if you guys can see or not. So, okay, so you have all these nice, pretty creases. You should notice that there is a curve right here forming. The inside of all of our creases have made this really nice curve. So what we're going to do with our marker is we are going to trace the inside of this. So right where my finger's going, the inside of our creases, we're going to trace this line. Okay, so so just follow the innermost lines. And if I forgot to tell you in person, kids, I'm sorry. If you're in class right now, all of these materials are on the little table by the whiteboard that I normally put stuff on where the bathroom passes are. Okay. So now we have a parabola. That's what Unit 4 is about. It's quadratic functions, and that graph is called a parabola. Woo! So this is what your paper should look similar to. Now, if you put your dot closer to your line, your parabola is going to be a lot more narrow. If you moved your dot way up here, then your parabola is going to be a lot more wide. That's okay. It doesn't matter. That just goes to show you that where this point is from the line, it does make a difference. And we're going to talk about that difference in just a second. But everybody should have a dot, a parabola, and then a line. Cool. I hope everyone has that. So now we're going to label this. This is not a good day to be absent. Sorry. All right. Do it like this. Okay. So at the top of your paper, please write parabola. That's opposite. Oh no. Well, okay. So this should say parabola. And then after you say parabola, we're going to define it as a set of all points. Okay, so a set of all points that are equidistant. Guys, equidistant just means the same distance. It's like equal distance from both the focus, I want you to underline that, and directrix. I want you to underline that. So here, I'll show you guys my paper. So the definition of a parabola is a set of all points that are equidistant from both the focus, everyone say focus, and directrix. Okay, I want you to all say directrix. I know they're funny words, they are new words, that's okay. Focus and directrix. Okay. I realize that it's showing up backward on there, but this is the best I got. Sorry. All right. So this point that we drew in the middle of our parabola, this is called the focus. Okay. The coordinates of this point are h, k plus p. Okay, and if that looks weird, focus is F-O-C-U-S. F-O-C-U-S. Okay. Directly below the focus is a point that we should already know. This is our vertex. Okay. And remember, the coordinates of a vertex are HK. This line, a horizontal line, this is the directrix. And the equation of this is y equals k minus p. Okay, so we have our focus, which is h comma k plus p, that's the coordinate. Our vertex, which we should already know, is hk. And our directrix is the line, and it's y equals k minus p. Okay. The round thing that we generated by folding all of our stuff is the parabola. Okay, and that's just what we call a quadratic function. That's the shape it makes. The graph is a parabola, and the equation is y equals ax minus h squared plus k. That's in vertex form. We've seen this before. Remember, a is our scale factor, hk is our vertex. Okay. So now that we've labeled it, I just want to show y'all this point. So notice how the vertex is labeled HK and the focus is HK plus P. That means that the distance between the vertex and the focus is P, right? Notice our vertex is HK and our directrix, the equation of the line, our y value, is K minus P. So that means that the distance from the vertex to the directrix is P. Well, that means that the distance from the focus to the vertex is the same distance as from the directrix to the vertex. Well, there's a reason for that, and the reason is because our definition says that it is a set of all points that are equidistant from both the focus and directrix. So what that means is you could take a point anywhere on the graph from the focus, like let's choose right here. This just looks like a cool point. We draw a line from here to here, and then we follow that line from that point straight down to our directrix. These lines have the same distance. So if you have a ruler, you could measure those and you would get the same distance. Same thing if you chose a point up here. Well, from the focus to that point is going to be the same distance from the directrix. Oops, not straight, to that point. Okay, and it is like that with any point on the graph, including the vertex, which is a point, and that's why that works. However, it's very easy for us to know the vertex, so we call that special distance between the vertex and focus our P distance. Okay, that's our P value. So this is what your paper should look like at this point. I would keep this. This is a really good note page that just has everything on it. Okay. I would ask you what your questions are, but yeah. Okay. So hopefully this kind of made sense. I know it's weird for recording. Hold on one second. So I have a Desmos for you guys. Okay, so I have a Desmos. This is the code. There's only one code. So it's going to be ZR9DU9, and I'll post the link to this on Google Classroom also. So it's a really quick, easy Desmos. Guys, make sure that you do this for attendance purposes. If you don't even like log into it or start it, then I have no way of saying that you were present or working asynchronously. Okay, so the first question, it asks you what the definition of a parabola is, and you will need to respond. Okay, the second one asks you what the equation of a parabola in vertex form is. Both of those things we talked about, both of those things I told you. So if you just watch the notes, you should be able to do that. Identify the blue point. Identify the green line. Those are easy, you just pick the correct one. Okay, this is draw the parabola. So guys, like when you draw, you're gonna like pick your points, right? And you're gonna draw your parabola. Okay, And then wherever it tells you like your focus is, you're going to pick a different color and you're going to put a focus. And then if it tells you your Directrix, you're going to pick a different color and you're going to put a Directrix. Now this is not the actual example. I'm just letting you know. Okay. Erase, erase. All right, guys. Cool. So I hope that this goes fine. And if you have any questions, just, email me. I'll try and respond if I'm not asleep or something. Okay. Bye, guys.